In this example problem, we're supposed to find the area of the triangle with these particular vertices. So we've got 0, 0 here, we've got 1, 6 up here, and we've got 5, 2 down here. So we've got our triangle, and we're supposed to do this with one or more integrals. To do this, we're going to have the equations of these lines. Now, two of the lines aren't too bad. I can talk about maybe line 1, line 2, and line 3. So if I look at line 1, its slope, well, this is 0, 0. So change in y over change in x, 6 minus 0 over 1 minus 0, that's just going to be a slope of 6. And its y-intercept is 0, so its equation is just y equals 6x. Okay. Line 3 is also pretty easy. It also has a y-intercept of 0. M would just be change in y over change in x, so 2 minus 0 over 5 minus 0, so that would be 2/5. My b is equal to 0, so I would have y equals 2/5 x for line 3. For line 2, what I would need to do for that is essentially use point slope form. So m here is change in y over change in x. I could take 6 minus 2 over 1 minus 5. So that's 4 over negative 4, which is negative 1. And what I get then is y minus y1 equals m times x minus x1. So y minus 6, let's say, is negative 1 times x minus 1. Y minus 6 equals negative x plus 1. So y equals negative x plus 7. Now, to set this up, if I imagine either vertical or horizontal rectangles, I'm going to run into trouble because I'm going to have to switch the definition of what the top and the bottom would be if I'm going with these vertical rectangles. If I go horizontally, I have the same issue. I switch which lines I'm going between at some point. What that means, I'm going to have to set this up with two integrals. I guess we're probably going to be more familiar with vertical rectangles, so why don't we split it into two this way. I called this line 1, I'll label that here. So if I draw in a little rectangle over here for this first region, I'm going to have to go between line 1 at the top and line 3 at the bottom. Whereas if I take a little rectangle in this region, I'm going with line 2 at the top and line 3 at the bottom, right? So on this side, I'm going between line 3 on the bottom and line 1 on the top until I get to this red line at x equals 1. And then from x equals 1 to x equals 5, I'm going from line 3 to line 2, bottom to top. So when I subtract my y-coordinates, I'm going to have to pay attention to which one I have. So to find this area, I'm first going to do this region to the left of the red line. So x is just going from 0 to 1. But then I have to take top minus bottom. That's going to be line 1 minus line 3 dx. And then I'm going to do the integral to the right of the red line. So that has x going from 1 to 5. And then I'm going to take line 2 minus line 3 dx. Okay. So we've got our equations for line 1, line 3, and line 2 up here. So line 1 has the equation 6x. Line 3 has the equation 2/5 x. Here, line 2, that's negative x plus 7. Line 3 is 2/5 x. Okay, so I increase the exponent by 1 and divide by the new exponent. Okay, so I've taken these antiderivatives, 6x squared, divide by 2, 2/5 x squared, divide by 2, negative x squared, divide by 2, plus 7x, negative 2/5 x squared, divide by 2, right? I divide by the new exponent. Let's see, can we do some cleaning up here? Sure. 2 goes into itself once, 2 goes into 6 3 times, these 2's cancel out, these 2's cancel out. So we plug in 1. 1 squared minus 1 squared over 5 minus 0 squared minus 0 squared over 5, all in parentheses, plus negative 5 squared over 2 plus 7 times 5 minus 5 squared over 5 minus, now I plug in 1, negative 1 squared over 2 plus 7 times 1 minus 1 squared over 5. So 1 minus 1/5 minus 0 plus negative 25 halves plus 35 minus 25 fifths plus 1/2 minus 7 plus 1/5. Oh, I knew I was doing something wrong. I knew I was missing something. Okay, back here, I forgot that 3, right? It wasn't just x squared, it wasn't just 1 squared, I had a 3 in front of it. So that should have been a 3 times 1 squared. So that's a 3 times 1, that's a 3. So, let's see. 3 minus 1/5, I can forget about the 0, minus 25 over 2, plus 35, minus 5, plus 1/2, minus 7, plus 1/5. Okay, so let's see. 3 plus 35 minus 5 minus 7. So 3 plus 35 is 38. 3 plus 38 minus 5 would be 33, minus 7 would be 26. Minus 1/5 plus 1/5, those cancel out. And now minus 25 halves plus 1/2 gives me minus 24 halves. So I get 26 minus 12, which would be an area of 14.